Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on concavity. By the end of this, you need to be able to use the second derivative to tell you when a curve is concave up or concave down. But we will go through all that. Let's start by looking at this graph here. So this is something like y equals x squared. So you can see it's a smiley face. It has a minimum turning point. So we figured out in previous video that when you have a minimum turning point, then the second derivative is positive at that point, okay? The first derivative is 0 at a stationary point, but if it's a minimum, has a minimum turning point, then the second derivative is positive, and I went through why that was in a previous video. So this next function would be something like, I don't know, minus x squared plus 4 or something like that. So it is a frowny face. It has a maximum turning point, and that means that the second derivative will be negative. So a function that looks like this first one, a smiley face that has a minimum turning point, it is said to be concave up. And the second one is said to be concave down. So the way you can remember it, smiley face, concave up, you smile when you're up, and you frown when you're down. So smiley face up is positive, a frowny face when you're down is negative. So that's how you can remember differences in concavity. But the truth is, a lot of functions aren't this simple. Some functions are concave up sometimes and concave down at other times. So let's look at this function here. So this function, you can see it's like a frowny face, but then it turns to a smiley face. It becomes happy. So this function here is actually concave up some of the time and concave down some of the time. So it's concave down when x is less than b, and it's concave up when x is greater than b. So point B is an inflection point. So that's basically what an inflection point is. We came across them in a previous video, but now more formally we can define them. Inflection points are points at which a graph changes concavity. These two functions don't have any inflection points because there's no change in concavity. This is always concave up, this is always concave down. But some functions change concavity, and at the point where the concavity changes, we call that an inflection point. Just to make matters a bit confusing, as I said, inflection points can be stationary or non-stationary. So this point here would actually be a non-stationary inflection point, but it's still an inflection point. So remember, inflection points occur when the second derivative is equal to 0. So where the second derivative is equal to 0, that's where changes in concavity occur. So we can tell just by looking at this graph, its second derivative will be negative in this area here. So when x is less than b, the second derivative will be negative because it's concave down, and we can tell that the second derivative will be positive when x is greater than b, and that's because it's concave up. So functions are concave up whenever the second derivative is positive, concave down whenever the second derivative is negative. So if y equals x squared, the first derivative is just 2x, the second derivative is just 2. That's why this function is always concave up. Its second derivative is always positive. 2 is always positive. On the other hand, if I differentiate y equals minus x squared plus 4, I get minus 2x, and the second derivative is minus 2. That's why this function's always concave down. Its second derivative is always negative. But as I said, some functions, the second derivative will be negative in some areas and positive in another area. All right, now we're going to practice where I give you a function and we find out where it's concave up and down. So without graphing this function here, we're going to determine when it's concave up and when it's concave down. So that's entirely determined by the second derivative. So firstly, we'll have to find the first derivative. So the first derivative of this function, 3x squared minus 18x plus 24. And then the second derivative will just be 6x minus 18. So, in order to determine when it's concave up or concave down, we need to find when this is positive or negative. So, if it's concave up, that means the second derivative, which is 6x minus 18, is positive. So you know how to solve this. Add 18 to both sides, divide each side by 6. You get that x is greater than 3. So this function will be concave up whenever x is greater than 3. So for concave down, it would be the opposite. 6x minus 18 would be less than 0, and you know that x would be less than 3. So what about when x equals 3? Well, if x equals 3, then the second derivative would equal 0. X equals 3 would actually be an inflection point. So we've figured out without graphing when the curve would be concave up or down. I'm just going to draw a picture of the graph now just to show you what's going on. So it turns out that the graph of fx would look like this one in red. So this wasn't part of the question, but it turns out it has a maximum turning point, x equals 2, a minimum at x equals 4. So it is concave down when x is less than 3. X equals 3 is a point of inflection. The curve changes concavity. It becomes a smiley face and is concave up. So remember, concave up, smiley face, second derivative, positive. When you're up, you're smiley, and that's a positive. The curve is concave down when it's a frowny face, and the second derivative is negative. You frown when you're down, and that's negative. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.